Capacitors store energy. When a capacitor is connected to a battery, there is a potential difference across the ends of the capacitor. This causes charges to build up on both sides of the conductor plate of the capacitor, with positive charges on one plate and negative charges on the other. Now, if we replace the battery with a tiny light bulb, the charges stored will flow through the wire as current and light up the bulb for a few seconds. So a capacitor is like a really small rechargeable battery that charges and discharges very quickly. In this lesson, what we will do is learn more about the energy stored in these capacitors. The total charge Q stored by a capacitor is dependent on the amount of voltage V across the capacitor and the capacitance C of the capacitor. This is represented by the formula Q is equal to C times V. When we lift an object from one position to another, we say work has been done, and potential energy is stored in the object as a result of the work done and the new position of the object. This work done is the product of the force applied and the distance it was applied through. Let's apply that method here. Work is done in the capacitor by moving charges across the potential difference, which we call voltage. So work done in the capacitor is given by the product of the charge and the voltage multiplied by 1 over 2. Why multiplied by 1 over 2? Because as the work is done moving the charge, the voltage goes from the maximum voltage to 0 across the capacitor. And half the voltage is the average between V0 and V maximum. Therefore, work done is equal to energy stored in the capacitor and is given as E equals to 1 over 2 QV. Also remember that Q is equal to CV, and so energy E is equal to 1 over 2 CV times V, which is equal to 1 over 2 CV squared. Alternatively, we can express E in terms of Q and C. Because V is equal to Q over C, then energy stored can be represented as E is equal to 1 over 2 Q squared over C. This energy that is stored and released during charging and discharging of a capacitor is applied to numerous electronics, which we shall explore in other lessons. Bye for now.